Hello and welcome to Intro to C++ Programming. This is the third terminology video. Once again, anything that's labeled with a 0 or dot whatever is going to be more so on the terminology, any pseudocode in there, no actual coding. So if you want to start, just jump right into the coding, you are going to want to go to a video labeled 1.1. Or anywhere else, I guess you need to go into the playlist. Anyway, let's continue. So, what you're going to be finding in this particular video is just terminology on key concepts of general programming languages, and we're going to start going into C++ specifics, where I'll be talking about syntax that you'll see, particularly in C++ programming, semantics that you'll see in C++ programming, and structures that you'll see in C++ programming. Yeah, now we start getting into the specifics for this particular language. So, terminology is what you'll be seeing across different languages, but we'll be using C++ as our reference point. So, let's just show off what a basic hello world looks like. This is the first program that you'll write in any language. Just either to get it set up or if you're a beginner, whatever. It's just customary. Now, of course, you could be like really edgy and, I don't know, write something else other than hello world. I think the first one that I did was either something to like do with Pokemon or just some emo garbage. I don't remember what it was and I don't feel like looking it up. But here's what we're going to be doing for our breakdown for hello world, right? You don't have to understand it right away, but this is what you're going to be including in any given programming language, because you're probably going to have some input-output, right? So this preprocessor, this header file, is for recognizing input and output. So you're going to write $, include, and then within greater than less than signs, you put input, output, stream. You're going to want to make sure that you write whatever namespace you're using, and what this does is just tells the compiler that we're just using the standard library. You don't have to include it, but I would recommend doing that just so that there's no confusion on the compiler's end. Could be a very stupid error, you never know. And it's using, which is a keyword, namespace standard. Then we get into the actual beef. This is our main function, and it's where the program execution begins. We'll go into it later, but the main method is in every program. Not necessarily in every class, but it's in every program. This is where you're going to be executing all your main junk, and you want to keep it as clean as possible so that you really only have what's necessary for executing in there. Obviously, this is really basic, so I don't have to get into that, but anyway, what you want to write for, in particular C++, is int, main, and then you have parentheses, open up your brackets, and you could also write std : before cout. It's not necessary, it's just to say we're using the standard library, don't get confused, blah blah blah. It's not necessary for this. So what cout is it's your way of putting output to your screen. So C, output. Then you put two less than signs, and you say in quotations whatever your message is. And if you want to end your line, you use a semicolon. And because it's of an int type, we just want to return 0, because that's our endpoint. We don't need to push anything back and forth. That's it. So return is going to show you your result, and cout is, of course, your print. So this is all the this isn't actually pseudocode, this is actual code. This is your actual code, and then this is the output that you're going to get on your little, like, black background, white writing console screen. Just written your first program, look at that. So, important thing to note as you saw stuff that wasn't actually code, right? Documentation. It could be anything from text, illustrations, or examples that accompany the software and or is embedded into the source code, which means this slash asterisk asterisk slash, that is some of the stuff that's quote-unquote embedded in the code. We'll go into commenting in a few minutes, but it's meant for like showing the requirements for the end user, or showing how you're implementing, or just little comments, documentation of like other people's code, or for marketing, which is probably what you'll see more in the illustrations. But in an intro class, we're only going to go over just writing it into the code itself. Commenting is meant as a reference for you, and it's meant as a references for others. Documentation is very important, especially when you're writing larger programs. Um, if you haven't heard this story before, the game EVE Online, crazy big spaceship game, whatever. Um, there was one guy who wrote it like since the beginning, and he got into like some car accident. So most of the other people on the team just kind of let him do his own thing because he was like super good, right? Well, they go to check his code, and he quite literally wrote over 1 million lines of code completely undocumented. Not a single comment. So the people are looking at this like, oh my god, how are we gonna do anything with this? So anytime they try to even like deprecate anything that he wrote, it would break the game and screw up the servers. It was really bad. So what they did to fix that is they couldn't. So the most that they could do was just make new features that basically replace the old ones, trying to just basically build on top of it and just stick some cement over it, just bury it, you know. They can't really get rid of it. So yeah, please document your code, otherwise you'll die and nobody else will figure it out. Anyway, it's probably not that harsh. It's a really extreme example, but it's a really crazy story. Anyway, commenting. It's an annotation in the source code written by the programmer and is ignored when the program is executed. So all those asterisks and slashes will not show up, which is great because a lot of people write stress relief in there. So it's usually for planning, removal, code descriptions, resource inclusion, metadata, debugging, directive uses, or where the compiler is going to actually read the line, and stress relief. So let's give some examples. So commenting, right? // is a single line comment. Within the // it's going to represent like the keyword, right? If we were to write something that was multi-line, it's that /*, and you have to end it with a */. And it's basically for if you want to have like multi-line, right? You can have the asterisk appear like right after, or it doesn't necessarily have to be as seen by that or not. It's easy to read, but if you're going to be using an IDE, it's probably going to generate the asterisk every time you press enter, and it's closed with */. So these two are for different languages. I'm just showing them here because when I wrote it, I was like, I'm just gonna write that in. These are both illegal in C++ for commenting, just so you know. Yeah, so in HTML or web design stuff, you'll be doing less sign, exclamation point, dash dash, and dash dash, exclamation point, greater than. Yeah, basically whenever you write like a comment and it isn't just like a single line one, you want to close it opposite how you opened it. And then as you see this pound symbol, we had to use it for include. In Python, it's the pound symbol, but in C++, it is for preprocessors. You do not have to worry about these two lines. They're just fun tidbits. And just to show off some stress release, fuck lol. Yeah. Also, if you write like multiple asterisks, it doesn't really matter. That's just a thing for style. Some of the style that you'll probably see most is like through like comments, honestly, and indentation. So indentation doesn't necessarily matter in C++, but Python it does. Again, fun tidbit. And as you can see, there's no results because this is not read by the compiler. It is completely ignored. So I brought it up here, but the pound symbol is for the preprocessors. They're shown at the beginning of the program. Stuff like that. Pound symbol include blah blah blah. Right. So variables. Variables are kind of important. So before I go into what they're used for in programming, do you guys remember in math when you had to use placeholders or variables, right? I kind of gave away the answer, but yeah, they're basically placeholders, and it can be anything you set it up to be. But it's easier in programming because it's not math, right? Anyway, yeah. So basically, a variable is a storage location with a memory address in the computer with some unique identifier which contains, I don't know, information, whether it's known or unknown when you write it. So during compiling, a compiler will replace all the variables and other symbols with the actual memory addresses. If you were to do some cool people debugging, you can actually see what the memory address is, but that's not really important here. So you can see where they're linked up. So there is a possibility that the data stored might change. That will be important down the line when you start playing with variables like similar names or other addresses. But all that you need to know is that variables are meant for storing stuff, right? So a constant is a variable whose value isn't going to change during execution. So you write it. I mean, obviously, if you're writing the code, you can change it, but at execution time, it will not change. So when you're writing a constant, just be careful with your values. You might have some really weird errors because you're trying to change a number that can't. Wow, did I duplicate that? I did. Okay, that's my bad. Anyway, yeah, whoops. This is supposed to be for scope. Anyway, what scope is the placement of wherever you are, right? So if we were to start from the top, there's things like classes. Within classes, you can have, say, a method. Method cannot be outside a class, and any, I don't know, like conditionals, looping, or variables. Now, variables you can put anywhere except outside a class. So you can put them here, you can put them in a method, you can put them in a conditional or a loop. Doesn't really matter, but you just can't place them outside. So scope is where you are. Methods you also cannot place outside a class. I think I mentioned that previously, but yeah, just be careful with scope, especially for a lot of beginners. There could be a lot of errors. Quite honestly, the most common error that you'll probably see is like you're going back to delete something, you accidentally miss a bracket, and your compiler or your engine's like, this seems to be reading in from, I don't know, like something higher above, and it's not. Why is that? Or you might have wrote in an extra bracket trying to just fix your deletion. There's a lot of errors. Just want to throw that out there because it happens more often than you think, and it's really annoying. Also, notice that for methods and classes, unlike when I have to write, say, a variable or just anything else, I don't put a semicolon at the end. Yeah, you don't put semicolons at the end of classes or methods. This is true of like most programming languages. Your compiler will yell at you, and it just doesn't make sense. Semicolons are meant for things within. So now let's just talk about some rules, naming conventions. So naming conventions are a set of rules for best naming variables and other identifiers within the source code, both syntactically and semantically. So let's talk about syntax first, right? Or semantics. Wow, did I just reverse that? Yeah, it doesn't matter. So semantics, let's just go over that first, because it's easier to read, right? Classes should be nouns with the first letter of every word capitalized. Use whole words when you can. Don't name it too long, please. Methods should be verbs with the first letter of the first word being lowercase, and every word after having the first letter capitalized. Variables should be written the same way as methods. Should be short, meaningful words, unless they're like temporary, in which case it doesn't really matter. You can just use like one letter. Constants should all be uppercase, with each word separated by an underscore. Just a side note, these are not hard rules. Your compiler won't yell at you, but it's really helpful. Also, please don't just put the in front of your like variables or any names. It's dumb, really dumb, and I will lose respect for you. No, I'm just kidding. But also, some people write underscores in front of like all the variable names. It's usually for like if you have an IDE that maybe just starts giving you suggestions for things. People do that because if it has an underscore in front, they know that they wrote it. Just that's a styling thing. Some people do it, I do it sometimes, but yeah, it's not necessarily any rule that you can't. Anyway, syntax. This is stuff that you cannot do. Your compiler will yell at you. So numbers and special symbols, like, the money sign, cannot be used for the first character of a variable in like any language. I mean, if you want, you can put like a 1 or something at like in the middle or like at the end. It just can't be used for like the first letter or character. Some things between different languages. In Java, while it's not illegal, you can put a space as your first character in a variable name, but don't do that. In contrast, however, say in C#, you can't use a space as the first character because it is considered a private variable. Yeah, I've never seen that, but again, don't do it, please. It's hard to read. In C and C++, however, an underscore, as I said before, you can use it. You shouldn't, because it's reserved for stuff in the standard library. In languages like C#, people do it a lot. In C++, don't do it. I know I brought it up, just don't do it in C++, so it's just a side note. Declaration. This is about variables, and it specifies the properties of an identifier, usually by a variable or something along those lines. And the difference between declaration and definition. Definition has the initial declaration of a variable to be used later. It may or may not be assigned any data. It's just defining it at the get-go. Versus just declaring it. Defining it is you just give it some meaning at some point. Declaration is just putting it there. It could be the same line. Really doesn't matter. Data type, right? So this is going to be the attribute of data that tells the compiler how to interpret it. In C++, remember, it's strict. You have to give it some kind of data type, some definition to it. I shouldn't say definition. That would be inaccurate. You have to give it some data type. Okay, so there's two different kinds of data types, primitive and composite. Primitive is embedded into the language. So some common types that you'll see are integers, which is some range of mathematical numbers that allow either only signed or, positives or unsigned. Whatchamacallit, yeah, or whole numbers, right? Unsigned does not allow negatives, sorry. Did I ever say yes? Assigned allows negatives, unsigned does not allow negatives. I'm just going to use this as a quick side note, but it's technically one of the assignment problems when you start programming, but there's technically a difference in the range of numbers, right? So, for example, unsigned will only go half, or let me see, yeah. Signed will only go halfway up to the range of representable numbers. So, let's just say we have, I don't know, like a representation of 256 characters. It's going to go from 0 to 255 in unsigned, but in signed it's only going to go from negative 127 to 127 positive. And of course we're subtracting one number because we're including 0. This is also going to be important for indexes, but it's important to know when you're dealing with numbers. It could come up, but you're going to see that if you're dealing with low-level stuff more. You might deal with it here, but I'm just going to go under the assumption of no. Anyway, floating points. Some numbers in math are going to be rational, and some are going to be irrational. This allows, floating points allow us to use numbers that are, within decimal points or fractions, whatever. So it is stored in binary and has single precision usually, which is just a regular float. It's going to allow us to show off 32 bits of numbers. And double precision, double is actually a data type in C++ that'll show off 64 bits. It's just a matter of how many numbers you can represent. There's also stuff like longs. I don't really use it very much unless I have some crazy big number I'm going to show off, but it's just another data type. And then characters. Characters are single letters, digits, symbols, formatting codes, and control codes. But again, single, except if they're a control code, in which case it might be multiple. But it's single, and it's represented using the single apostrophe. And then there's booleans. Booleans only have two possible values, true or false. We could get into stuff like a truth table, but it's not necessary. Just have an idea of whatever you're assigning, whether it be true or false. Just keep that in mind. Composite. So this is a data type that can be constructed out of primitives or whatever's built into the system. Ones that you're going to commonly see that aren't user-defined are are strings. That's going to be made from the char types. It's different from chars in that it uses well, obviously you can have more than one character, but it uses double quotations instead of singles, and it can be used to store like a sequence of characters. So arrays, why do I keep doing that? Ugh. Anyway, arrays are a systematic arrangement of similar objects. So a bunch of ints thrown together, a bunch of doubles thrown together, a bunch of characters thrown together. You cannot have an int and a char in an array together. They have to be their own separate things. Lists are a countable number of ordered values that could be multiple, necessarily matter. And structures, or struct is the keyword. And that is a fixed set of fields and members which are publicly accessible. Structs are exclusive to C and C++. You will get into this argument later, but they're like functionally the same as classes. So that's why they're not necessarily in other languages. It's just another keyword, another thing you can use. There's technically a difference, and people use them for technically different things, but functionally they're the same. And then, of course, there's user-defined types. So, let's give an example of using primitives. This is just using an int. So we can just, not assign it a value. We can just say int I. Int I equals 0. This is defining it instead of exclusively declaring it. We can do it on the same line. We can just do it elsewhere. Doesn't matter. Unless you have to assign it beforehand, in which case it does matter. Anyway, multiple values can also be declared on the same line. So you can have int I equals 0, j doesn't equal anything, k equals 1, and then I don't even know what O is. So let's use primitives and float and doubles. Functionally, or I shouldn't say functionally, they're not the same thing. They have different values that they can represent. So float, say value is 3.69f. You don't usually have to, but just in case, floats are declared with an F at the end of the numbers. It's just easier to read. C++ shouldn't yell at you for that. Doubles, again, you could put like F or like D at the end, but don't have to. I never do. We can assign it whatever value, and again, these two are allowed to be decimals. Double represents more values. So even with ints, you can do the below. Arithmetic can be performed when declaring a variable. Sometimes it's good to just declare it on one line if you're not dealing with that much. If I really wanted to, I can take, let's just call this val2. We'll just change the number, right? If I wanted to, I can say this and then just change this 2 over here with like val2. Yeah, I can do that too. Did I just start deleting shit? No, okay. So let's do a char primitive, right? We assign it by, again, using the single quotations. And we do next bool, or boolean. While in most languages, an undefined bool is assigned a false value, in C++ in particular, it's garbage if it's a global variable. Like if it's in like a method or something, then it's not going to be a garbage value, it'll still be false, but if it's outside a method, it will be considered garbage and therefore unusable. So if you want to be safe, always declare beforehand. Personally, unless I absolutely shouldn't, I try to define beforehand. It's just easier for me to read personally, and excuses any errors that I can run into. So, strings. This is starting to get into composite, right? So, I can just define a string, it's not assigned a value. If I want to assign it a value, I do the double quotations, and as you can see here, haha, funny moments. So, because string is a method, not just any old type, we can use, not a method, an object. We can use methods, or we can give it some kind of attributes. We'll get more into that when we talk about, like, objects, but, this particular method that we're just doing, this dot length, there's nothing that needs to be passed. Before we get into it, basically, if something is an object, we can treat it as like a variable or a type of variable when we're calling it, and we can assign it different methods that we can use to manipulate it, or different attributes that it can have, and change them accordingly. Unless we can't, unless they're like just static and we're just calling them to be whatever, right? And then parameters are going to be whatever we're passing to manipulate that data. So, composite types, let's talk about arrays. Array sizes in C++ and most other languages need to be definitively assigned as soon as you get it. The size could be a variable made elsewhere, so you can have some change, so long as the types are the same. So here we can define it by just, without really declaring it, so we can put in whatever values that we want, but the array size is going to be 5. Now, the index count is going to be 0, 1, 2, 3, 4. And that's because, again, we start with 0, so even though it's 5, the index count only goes to 4. Now, if we want to definitively say what's going to be in there, like the values, we don't write the number in here, we just kind of explicitly define it, we use brackets. So let's just say the array size is definitive, but the values don't add up to the size, right? So we can just say, I don't know, here we have 6, right? The compiler is going to fill in the extra values as zeros. So here, even though we explicitly define it as, like, we have, what, 4 values, right? We say it's 6, we're going to be filling in these 2 zeros. This is going to be more when we get into, like, implementation of, like, different algorithms or, like, different methods or whatever, but, like, we can switch the placement. Like, we don't have an issue doing that. As you can see, this is not really sorted. So we could sort if we want, we just can't add more to any given array. That's the only thing. So let's talk about structures. Structures and general functionalities of programming languages with the perspective of C++. So, output. We already gave it a definition in the first of the 0 videos, but output is what you're going to be seeing on the screen as a result of some information given. It's a little more precise. So the way it's considered in C++ is that input and output are streams of information, right? So the stream is going to be the direction of any given sequence of, like, the actual bytes, and it's flowing opposite from the source and to a destination for the output. The input is whatever information that you're feeding it that will later be used to be sent to some destination. So an input stream is the direction of a sequence of bytes carrying data to be used in the program. It could be an intermediary, it may not necessarily go directly to the destination, it's just being carried somewhere. So let's have this little diagram to consider an input and output, right? So we'll start from here. We'll have our source input. We're passing it through this little stream here into the program, and then the program, I don't know, may manipulate the data, may just send it back, doesn't really matter, is going to spit out that input stream into this output stream, and that'll eventually go to this destination. So what's a non-inclusive list of types of inputs and outputs? Inputs can be stuff like the keyboard, the controller, some file, a network, or a program. The output is, you'll see it in, I don't know, like a console, a file, a network, a program, could be anything. Maybe you just see some kind of output in the controller. Like, I don't know, have a wavebird and maybe the output is, like, vibrating? Something like that. It doesn't have to be just this. So, let's have an example of just output, right? We kind of saw it in Hello World, but let's just take another look. So we have our header file, which will read in the input-output stream. There's no exclusively input, exclusively output, it's both interconnected. Anyway, we want to make sure the compiler knows we're using the standard library. We write the main function, that's where everything happens. And just as quick side notes for some things we may have not seen the last time, endl or endline just adds a new line afterwards. Personally, I like to have my output be as readable as possible. I try to space things out, so I write endl a lot. You don't have to, it's not necessary, it's just readable. And then again, output uses the less than sign to capture it. That's what we do in our stream, right? So let's just print out what's happened in endl, and it'll print out what's happening. And again, we could put the std : before cout. That's just saying that it's from the standard library. It's fine that one has it and the other doesn't. It doesn't matter. And it'll print out a LMAO, as we can see here. And we just return 0 just to stop the program. So let's talk about input. So let's say that we have our header file, and we want to make sure the compiler's using the standard library, start up the main. So we're going to just make this quick variable called name. It's going to have 20 characters that you can put in. We could have made this a string, but I don't really feel like doing that. So we have our output to ask what the name is. So input is the opposite of output, right? So we have greater than instead of less than. So input needs a variable to hold the value in place. Input always needs to hold the value in place, so we just need some holder. Instead of C out, we have C in or C input. And we do : name, and we have, I should have probably put an end line there, but whatever. So I put in the characters of 3 underscores. So, I mean, I could have just considered that a placeholder, but no, because I put it in directly as 3 underscores, I don't have anything telling me that's illegal, it'll actually print out the 3 underscores. So, when writing the output, you want to consider the spacing, because if not, like, if I don't include the space between, like, hey and the name, it's just gonna be like, hey, underscores directly right next to it. Like, just try to think about it. It's weird when you first start, and then when you get used to it, it's like second nature. And then of course we return 0, and we get the results. Okay, so let's talk about flow control. We'll consider this topic too. The first videos of like 1 point whatevers, that'll focus pretty much only on input output. This will be our second topic. This will be focusing on flow control. And I'll break it up into 2 pieces. That'll be for conditionals and repetition. So, generally speaking, flow control is the order of your statements, methods, or functions will execute. Object-oriented, it is technically procedural in that, like, whatever sequence that you're writing the words, if I want to, I don't know, have like 5 different methods, we'll call them A, B, C, D, and E, right? When I call them in main, I can do A on one line, B on another line, D on the next line, C on the next line, and E on the last, right? It's only going to execute whatever I write in the sequence. Object-oriented has the addition of just making things a little nicer in terms of organization. But anyway, what we're going to be talking about here for flow control is that it distinguishes imperative from declarative, and if we were to consider this as hardware, we can consider interrupts and signals as low-level equivalents. Anyway, that doesn't really matter for you. Let's talk about conditionals. Conditionals are going to check whether or not to execute a statement based on some kind of flag. Conditionals are just a fancy way of saying if statements. So the types of conditionals, there's an if-then, which means when writing you're only going to write if, and if-thens are if Boolean statement is true, then execute the following. Note that I'm saying Boolean, you don't have to write is true, is false. You just have to have something that has only one correct answer. It doesn't have to just be bool. If-else, and I could just write then, but anyway, if-else is going to have an if statement, then right underneath that is kind of an else statement. So if the Boolean statement is valid, then execute the following. If it's not valid, or else, execute something different. If-else if is basically saying, if the Boolean value is valid, execute the following. Else if, which is us still writing the actual condition, execute this. Else, execute whatever else. And there's also the switch case. I think most people still use just if statements, but if you see a switch, I'll just give you a definition. It's the same thing. But if case 1, then execute. Else if case 2, then execute, and you just write a breakout statement. You can nest conditions indefinitely. You shouldn't, but you can. So, let's talk about looping. Looping executes a block of code until some kind of condition is met. There's technically 3, but one is like the exact same as while, so we'll just mention it at the end. There's while loops, which execute indefinitely until the condition is reached. While loops are good for if you don't know how many times you're going to need to execute a statement or a block of code. For loops are you execute a number of times based on whatever your condition is. It's good for if you do know how many times you need to execute. You can nest loops indefinitely. just like if statements. You shouldn't, that's actually even worse in terms of debugging, but you can. Now, what's that one that I was talking about, the third type? There's something called a do-while loop. It's really old. It's the same thing as while. You can see it, and it'll be the exact same thing. Like, at least switch cases are still in use. Nobody uses do-while. You can write it, it'll be fine, but there's no point. I should also mention that while and for, if you can write a while loop, you can write a for loop. If you can write a for loop, you can write a while loop. Personally, I try to write for loops instead of while loops because I like writing my conditions right then and there. I don't dislike while loops, I just try not to use them. Again, functionally the same, exactly the same. Anyway, so let's have these little diagrams for our conditionals, right? So, blah blah blah, whatever's written above the program. Let's start at our condition. If it's true, then we execute our block of code. If it is false, then we just skip that block of code and we go on to the point after the if statement. Now, if true, there could be anything in that block of code. It could just be a simple print statement. It could be a whole loop. It doesn't really matter. It's just whatever the block of code is. If it's true, you keep executing that block code until there's no point for you to do it anymore, and then you get out. So, an if-else is whatever's above the condition, and we hit the if statement. If true, we go to this block of code. If else, or rather, else if, or, no, I'll just say, else, right? So, if true, blah blah blah, we'll execute this block code. Else, there's no condition written if it's just else. We just execute whatever's in that else block. And again, we just execute that block code until there's nothing left, and then we hit our point outside the loop, or not the loop, the conditional. Else if, blah blah blah, whatever's before we go into the condition. Let's consider this our if. If condition, if true, we go into this block code. Else if, because the if is still there, we're still writing out our conditional, and if true, we execute that block code. Else if, we just continue executing that block code inside there, or just else, we just exit back. So, let's talk about looping for a while, right? So, we just execute whatever's above. We have our condition. If it's true, we go into the block code. And we keep looping and looping and looping until it's proven false. So, important to note for while loops. Obviously, all loops require some kind of initialization, because if not, you're going to be stuck there forever. But, here's the key. While loops, initialization takes place before the conditional. And, whatchamacallit, incrementing and decrementing happens within the code. Not that it doesn't happen in for loops, it's just more explicit up top. Here. For the for loop, we have whatever's above, and when we start writing the for key code, we write our little initialization. So, initialization is going to be the, we're going to have our declaration, so whatever we're going to be using probably as our counter. Then we're going to have our condition, which is whatever our condition is going to be. And we have either an increment or a decrement. So we keep doing that until that condition is true. So similar to the for loop, actually exactly the same as the for loop, we go into that condition. If true, we hit that block code and we keep looping and looping until it's false, and then we get out. So again, for for loops, initialization takes place like right when you write the loop. And incrementing and decrementing still happens at the end, but again, it's more explicit up top as to what you're doing. So let's move on to the conditional examples. I could have moved this around when writing, but I didn't. Anyway, here we have a regular ass if statement. So if some condition, if true or valid, it's going to be executed, and you don't need to write like end statements at the end of the brackets. Some people do it. I'm just doing it for you. I never do that. And let's just make a couple notes down here, right? So this is the less than sign. This is the greater than sign. If else. So we have if the condition is true, execute that block. because it's just else, there's no if there, we're going to be executing this block if the condition above was not valid. So, and we just end the if. So one important thing to know about else's. Else's are connected to whatever the if statement above is. There is no separation of the two of them, as in like you can't just write like a little variable in between this bracket and this else. Else is connected to whatever's above. Even if it's an else if. Very important. This is how you represent greater than, or less than, and greater than. So let's do an if, else if. Wow, I have a lot of errors in this one. Disregard this. If condition 1 is valid, we're going to execute this block, so long as this is valid and condition 2 isn't. Condition 2, or else if, notice how we're writing this, even though it says else because there's an if here, executed if condition 2 is valid, but condition 1 isn't. And then else, just as its own, conditions 1 and 2 are both not valid. This is how you show equal to, this is how you show not equal to. Just a quick note on that as well. If you are comparing primitives, this is all good and legal. If you are comparing composites, you use a method like dot equals or equals to, whatever the kids use. Just want to throw that out there. And then switches. They're functionally the same as ifs. So switch, we're going to write the condition up top, and then within the brackets we write case 1, colon, whatever we're going to be using in our blocks. Breaks are how you get out of switches. You don't need them in every case, again, because it could be like a loop, but it has to be somewhere. Case 2, block code to be executed. Also, just a quick side note, defaults cases aren't needed, but they are helpful. And again, if any of these cases aren't really true, it's just what you default to, and you break out of it. And this is how you do an AND statement, this is how you do an OR statement. Okay, so let's start looping, right? So we have our while condition. So whatever is going to be in that block, we execute until it's no longer valid. So here we have our loop. This is how they're written differently. So we have the initialization, the condition, and the increment or decrement. And we just keep looping until it's no longer valid. Okay, now we start getting into the fun stuff. This is right before methods, but I'm just going to bring it up before methods anyway. Because it's not really useful otherwise. So pointers. Great, beautiful mess. Pointers are a value that can indirectly access a particular variable or other identifier in a computer's memory. So, differences between pointers and references. References, an alternative name for an already existing variable. So, when we write pointers, which are a C++ thing only, we have whatever our data type is going to be, our variable name, and let's just set it equal to some assignment. Doesn't really matter, right? When we write pointers, the key for that is after we declare our data type, we put an asterisk, and we'll just call it pointer. And whatever we're assigning it, we put an and before. References. We have our data type, we assign it, whatever our variable is. We only put the and. Very key difference in C++. I'll get more into when we do like actual examples, but very key difference. So, let's talk about parameters. I promise, we'll get to methods really soon. So what a parameter is it's an argument value passed to the method to be used as input for the subroutine, or, a method. See? Getting there. So, passing parameters. There's two different ways to do it, and this is true for, like, most languages, right? So, there is value, where it passes, not the actual value, it passes a copy of the value rather than the actual, meaning that any changes that you do to that parameter within whatever the scope it's in, it's going to remain in that scope. So I don't know, make some value A, I push it through a method, and I just keep adding on it. It's going to return the value, but it's not going to change the actual. Now reference passes the actual, so any changes that you do are going to be, shown when you get out of the scope. So, finally we're there. Methods, also known as functions. Methods are a procedure or routine associated with some object that performs a certain task. It is reusable and helps organize the code. It doesn't really matter for the beginning, but like, don't write everything in main. That's the idea. So, we're going to be talking about how to call methods with the same name, because this is kind of important and a little confusing, kind of like the passing. So, calling methods with the same name, there's two different ways to go about it. There's overloading, which is when there's two or more methods in a class that have the same name, but different parameters. So you can either change the data type, the parameters in them, it just needs to be changed somehow. Overloading is for compile time, and it's used when the child class has a new or added functionality that the parent doesn't, right? So, overriding is when 2+ methods in a class have the same name, but one of them is in the parent class and the other is in the child class. Very key difference. So overriding is for runtime, and it's used when methods need to perform a similar or like the same job with a different parameter passed. So overloading is on a smaller scale, overriding is on a larger scale. So yeah, let's just talk about this a little more, right? Inheritance. So overriding requires inheritance, overloading does not. So scope. Overriding takes place in different scopes, or straight up different classes. Overloading takes place within the same class, or the same scope. Function signatures. Overriding requires signatures to be exactly the same. Overloading requires either like a parameter or like a data type change. So, let's talk about just a method, right? Have whatever the data type's going to be, the method name, and a parameter if we want to pass it. That's the function itself. We write whatever statements, and unless the data type is void, we have to write a return. So, the main method. Main methods in C++ are ints, or is an int. We write the statement, you can execute a function by calling it, and we just return 0, and then we end main. Let's talk about overloading. Now, overloading, remember, is in the same scope. So I don't really want to return any types, right? So I have some function, I guess I just name these all the same, right? Yeah, okay, good. No errors here. So some function, and the parameter passed is a constant int called I. We write whatever statements that we want. Given what we have here, it's probably just a print. Void function, we have a different parameter type, double F. We have a function again, and now it has a pointer of char C. Now we write our main method. So, let's call them. Function 10F, right? Because it's a float. Okay. No, sorry, it's a double, same diff. Function 3, that's our constant. And the character type, it's a pointer. So, la. So, in the order that it executes, it's 10, which is this second one, 3, which is our first one, and char, which is our last one. Then we just return 0. But notice how these are all the same name, but they have different, like, parameters. I could also have just changed the type, didn't really matter. Overriding. We're going to split this up into 2 separate slides, just to make things a little easier for their eyes. It's me writing. So we have our base class, which will talk as a parent, and the child class, which is inheriting from parent. We won't talk about inheritance in this video, but when you're dealing with inheritance in C++, you write this colon, and you indicate the indicate where you're inheriting from after the colon. So, with our class, we have the method that we're going to be overriding. Now, when you're writing overriding code in C++, you want to make it a virtual like method. I'm not going to talk about virtual methods, classes, all that crap here. I'm going to do that maybe in the next 0 video, the terminology video, but it'll be a bit before I do that. Anyway, You want to make it virtual, whatever data type you're using, whatever you're calling it. So, when you want to use it in another class, the child class here, right? We write the keyword override above it, and we write void, which is the type, and the name. Maybe, no, wait, we can't do parameters. This is, it has to be the exact type. And then we just have this second void. Now notice how I have semicolons here. I'm doing that because I'm doing more interesting things to these methods here. So, main. We have type parent, we're going to call it parent, and child, we're going to call it as a reference, and we're going to set child equal to this parent type. It'll be allowed to do that because we're inheriting. So, let's call the parent version of this function, and call the child version of function 2. Because it's within child, I didn't necessarily need to write it, but it's easier. And then the child version of function. Now, I didn't really assign anything to these. I could have just put a print statement, but parent function, if there's anything special that we do to it, let's say blah, right? It'll print out blah. Function 2 will put lol. It would print out lol. And child function, it would print out a child version of function. Let's just put buh. Yeah. So, I'm real good with print statements and naming things, ain't I? Anyway. Void. It's technically a data type, but I put it way down here because it's not really a data type. So, in terms of C++, it is an incomplete data type with an empty set of values. So, objects and references cannot be of type void, which is why I didn't want to talk about it before. However, a pointer can be a type void. Void is used for function return types. That's what it's used for pretty much. It's not a proper data type. So, let's talk about setting stuff to nil. I'm going to use nil because null is a keyword. So, when you're dealing with primitive data types that have their values set to 0, to nil rather, you can have some basic initialization or maybe another variable to hold it in place if you're going to change it later, or some other third thing. It doesn't really matter, but when you have a primitive data type, your nil quote-unquote value is going to be 0. So that's a very key difference to, say, objects, which need to be set to null, because as objects, what their nil value is isn't really clear. So null is more descriptive than 0. Like, I can't necessarily say something like a string is equal to 0. Like, no quotations, just 0. Because, well, for one, it's going to give me a type error, but otherwise, it's going to be like, wait a minute, what does that mean though? Because we have a lot of things we're going to be pushing back and forth. What does that mean? So it needs to be null or string. It could just make it like an empty string, I guess. But your nil values are going to be very different. Classes. Classes are objects that provide initial values for the member variables or attributes, as well as implementations for their behaviors. Behaviors meaning methods, attributes just meaning, I don't know, whatever variables you throw in there. So, objects are a particular instance of any given class, where it can be a combination of a variable, functions, data structures, whatever else. And because of this, it has a value in the memory referenced with some identifier, or a variable. And an instance is a concrete occurrence of an object existing at runtime. They are called by constructors and destroyed by destructors. It doesn't really matter about destructors here unless you're dealing with low-level stuff. Constructors are important, though. Constructors are a method for a class that initializes an object of that type. That way it can be used elsewhere. So not every class needs a constructor unless you plan on using it elsewhere. And you want to give it some setup of some kind. So before we go into some of the pseudocode or whatnot, I just want to go into accessibility. And accessibility is how members of a given class can be accessed throughout a program. So specifiers, and you might see this in your writings, is Like public, private, or protected. Public means that it can be seen anywhere throughout the programs, or outside of class. Private means that it can't be accessed or seen outside of that given class. Protected means that it can't be seen outside the class unless it's like a child, or a child class. So let's give a quick example of classes. And again, we'll just be splitting this up to make it easier. So we have the class, and we have these values which are going to be publicly accessible. So you can see public and the colon. So we have, I don't know, whatever these datas are and these variable names. These are going to be considered as attributes. Constructor, which doesn't necessarily need a parameter, doesn't even need anything written in there. But if we want to use these later, this is how we're going to set it up, right? So let's consider this var name of 1. We're going to set that equal to v. And var name 2 is going to be v1, so on and so forth. And the constructor, let's just make up a method. And we're going to pass a parameter. So executes whatever statements, ends method, end class. Put it into main. We want to call a class name, whatever we wrote for our class. This is the object of the class, right? So we assign some new values by doing cn, or our object, dot var name 1. These are the attributes that we're accessing. We're accessing, again, the attributes, those variables that we set up. And we're just going to assign them some new value in main. Now, if we want to call the method, we do cn, and we access it by the method name. And we can do the method by closing that off. Now, let's make objects, or instances rather, of the class name using the constructor. So, we have our class name, write out the full thing. Let's make a new cn1. And this is what we're passing through. cn2, we're going to be passing through these values. So, I'm getting close to the end here, don't worry. I know it's long. Structures. I brought it up before, not in this video necessarily, that they are functionally the same as classes, but let's get into the differences. Structures are user-defined data type, just as classes are, and can group items and or functions to be used together later. So, just a quick note. Values cannot be initialized in the structure. When they're initialized elsewhere, you need to use brackets. This is, again, an exclusive C++ feature, this thing. When you're calling, when you're calling structures, they're called the exact same ways as you would call a class. And we can use, actually no, we can't use, I mean you can, but you shouldn't. Using typedef in front as the keyword is obsolete. I suppose you can do it, but we don't. Nobody does that anymore. I mean, you can, but you shouldn't. Structures versus classes. There's no performance differences. They can both do inheritance. They are functionally the same. I want to make that clear. Accessibility. Members of a structure are public by default, which means that they're less secure. Members of classes are private by default. You can change the accessibility, but doesn't really matter. Preferably, you should be using structures as like regular data structures and leave more complex tasks to classes. By all means, they are functionally equivalent. So let's write up a structure, right? So we use the keyword struct, and we write whatever members that we want in there. It's like the same as a class, and do some members. We get the objects. So if we want to put objects together, right? We have our members, and then we write the objects at the end. So again, we use this semicolon for the setup, and then objects, we have the semicolon at the end here. So I'm not going to get into structures until way later, but this is what I use for my presentation design. Thank you to SlidesGo, Flaticon, and FreePick for these really radical templates. And thank you very much. If you guys have any other questions, shoot me a message, leave a comment, do whatever. Alright, see you people later.